Okay, good morning everyone. Welcome to this DevOps presentation on security best practices in application deployment. My name is Clive Payne, and I've been working with Progress and OpenEdge since 1994 with version 6 onwards. Over 30 years now. During my career, I've held various roles in sectors ranging from finance to healthcare, but my passion has always been in optimizing and securing development workflows. At consulting work, I specialize in designing continuous integration and continuous deployment pipelines using tools like Jenkins, Ant, and Groovy. My focus today is on improving security in these processes. Consulting Work is an independent IT consulting firm headquartered in Cologne, Germany. We've expanded globally with subsidiaries in the UK, US, and Romania. We're known for our expertise in OpenEdge and our commitment to modernizing legacy applications. We help organizations transition to modern frameworks, including .NET and Angular. Our clients span various industries, and our goal is always the same: to drive innovation while ensuring security and stability in their systems. Our services include Progress Software, products like OpenEdge. We also work with Telerik DevCraft for .NET and Kendo UI for building responsive web applications. In addition, we offer monitoring solutions like WhatsApp Gold for networking infrastructure and Cortican BRMS for business rules management, ensuring a robust development and monitoring ecosystem. These tools, when used together, form the backbone of secure, scalable, and efficient development environments. We complement our core offerings with related products like Protop, a critical database monitoring tool that helps secure your data environments. We also support Combit, List, and Label for reporting and various web frameworks, including Angular and Java, providing flexibility in your technology stack. Elasticsearch and AWS also play key roles in our deployments, and our expertise in DevOps tools like Docker, Jenkins, and Gradle ensures we can automate and secure development pipelines effectively. So here's what we'll be covering today: why security matters, database security, binary-only deployments, PASOE encryption, development workflow, Jenkins pipeline, and artifact storage. I'll be walking you through each topic with a focus on practical implementations, highlighting the most significant security concerns in DevOps environments and how you can mitigate them. For example, in the Jenkins pipeline section, we'll cover matrix-based security and configure credentials securely. So, starting with why security matters. Security is a top priority in DevOps because the threat landscape is growing at an alarming rate. A recent projection indicates that the global cost of cybercrime will reach $10.5 trillion annually by 2025. With the rise of DevOps, pipelines have become prime targets for attackers due to their automated and often interconnected nature. Threats range from pipeline poisoning, where malicious actors inject compromised code, to unauthorized access across various systems. One key point to remember: securing your pipeline isn't just about protecting the code, it's about safeguarding the entire ecosystem, the code, infrastructure, and data. There are several recurring security issues in DevOps pipelines. These include exposed credentials, unsecured APIs, and poor access control. One of the most prevalent issues is unsecured CI/CD pipelines. Without proper access control, malicious actors can tamper with your code or insert vulnerabilities, causing significant damage. Another major issue is code tampering. Attackers can modify your code during the build or deployment process if proper safeguards aren't in place. That's why securing every stage of your pipeline is so critical. For example, consider the risk of hard-coding credentials into scripts. If exposed, they can provide a backdoor into your system. The attack surface in DevOps is vast and includes multiple layers: source code, infrastructure, the deployment pipeline, and database access. Each stage of the CI/CD pipeline, build, test, deploy, can be a potential entry point for attackers. For instance, your source code might be secure, but if your deployment pipeline has weak access control, an attacker could gain access to critical systems during the build phase. Security isn't just about protecting the code itself, it's about protecting each touchpoint of the DevOps lifecycle. As we increase the frequency of deployments, we introduce new complexities in managing security. Automation, while increasing efficiency, also increases the number of integration points, each of which could become a vulnerability. Take a Jenkins pipeline, for example. A typical setup may include numerous plugins, each adding its own security risks. You need to consider, monitor, and update these to ensure they don't introduce vulnerabilities. The more complex your CI/CD pipeline, the more robust your security measures need to be. In today's world, regulatory compliance is a major driver for implementing strong security practices. Let's look at GDPR, for instance. It has strict data protection for privacy requirements, with non-compliance leading to hefty fines and significant reputational damage. Another key regulation is PCI DSS, which focuses on securing financial transactions. Failing to comply with these regulations can lead to severe penalties and data breaches. Organizations need to ensure that their DevOps pipelines are compliant with from the very beginning to avoid such issues. Data breaches can result in irreplaceable losses of customer information. Non-compliance from regulations like GDPR or PCI DSS can result in substantial fines. The reputational damage from security failures may take years to recover from, as customer trust is difficult to rebuild. Business disruptions caused by poor security can lead to significant revenue loss and operational downtime. Security lapses can create long-lasting damage that impacts an organization's overall competitiveness. So DevSecOps is the evolution of DevOps. It integrates security practices directly into the DevOps process. This means that security isn't something you tack on at the end. It's embedded into every phase from design to deployment. By automating security testing and implementing continuous integration of security tools, you create a much more resilient pipeline. Okay, so that brings us to database security. In OpenEdge, switching on database security is as simple as enabling the disallow blank user's access at runtime functionality. But knowing when to switch it off is just as important. This feature updates the database's metaschema to enforce security protocols, which is crucial for environments handling sensitive data. There are two ways we can switch the OpenEdge database security on. The first is manually through the data administration menus, and the second is we can do this programmatically, which gives us far more flexibility with regards to automating this process through our deployment scripts. Here we can see the manual approach via the OpenEdge database administration menus. If you are connected to multiple databases, make sure you are currently selected database is indeed the one that you wish to perform this feature on. When you select this menu option, an alert box will appear informing you of what this feature does and if you are sure you wish to continue. It is worth noting that you can switch the security on from the menus, but you cannot switch it off from the menus, which is another reason why handling the security feature programmatically is recommended. If you do decide to use this approach, then it is important to document changes made through the menus for audit purposes. Here we have a snippet of some simple code that does the exact same thing as if we were using the menu option from the previous slide. As we can see, it's looping through the metaschema_file table, where the table type is T. We then assign the exclamation comma asterisk value to all of the can fields. Notice we are performing this in one single transaction, as we do not want to partially perform this feature if it crashed midway. Highly unlikely, but coding standards should dictate this. And of course, we are passing an error if we hit a problem, which is all pretty standard. And here we have the same piece of code, more or less, where we loop through the same metaschema_file records to switch off the database security. The only difference is we are resetting the value of the can fields back to asterisk, which is the default value, to allow data access to everyone again. When this code is run, then they have effectively switched off the database security. This is the only way we can switch off the disallow blank user access security if previously switched on. Considerations. While security is on, connections to the database remain possible without giving user credentials, but data access is restricted. Switching off the database security should only be a temporary measure to allow database maintenance or cloning of your database for test environments. If we have a separate database security module in our deployment suite, we can easily perform the switching on or off of the database security as required. This way, we can enforce switching back on the database security when performing standard deployment tasks. For example, when restarting the PAS-OE, it will fail if the database security has been switched off or running a new deployment. As part of switching on the database security, we should prompt the deployment administrator for the database credentials, the username and password. We will then need to create the _user record prior to switching on the database security, otherwise we will no longer be able to access our data. Maintained credentials should be prohibited to only allow the updating of the password for the existing _user record. Switching off the database security should include the deletion of the _user record. The reason for this is to avoid conflict with encrypted credentials stored in our hidden deployment properties files. It keeps things simple in case we have a crash during the management of our credentials. The last thing we want is to have a database security switched on with no _user record or out-of-date credentials stored in our properties file. Both scenarios would essentially lock us out of our database. If we want to change the username, then we should switch off our database security to delete the user record and then switch the database security back on to create the new credentials with the new username and password. Now that we have our database security switched on, we will need to connect to these databases with valid credentials. Starting with our deployment processes, we will need to manage our databases for a variety of reasons, to either update our schema with incremental DFs or load data. For these purposes, we need dynamically generated PF files to connect to our secure databases, utilizing the -u and -p parameters. We will also need to connect securely from our PAS-OE agents, where we have two options available. Either supply our credentials in the openedge.properties file, something we do not recommend, or programmatically, which we do recommend. I'll explain our reasoning for the preferred approach later on. For our deployment scripts, connecting via the use of PF files is suitable as they are temporary files created solely for the deployment process and are purged immediately after use. That said, we still need to use encryption just in case something goes wrong. We recommend encrypting passwords using the GenPassword utility and passing the encrypted password directly via the -p connection parameter. Details of using the GenPassword utility are available from this URL. The benefits of this approach is that there is no decryption required. OpenEdge does that for you. So you can use the generated encryption value directly as the -p value in your PF file. This means we have secured our credentials in a quick and easy way that is suitable for our deployment scripts. Here is an example of an Ant script macro that generates an encrypted password using the GenPassword utility. As you can see, we are passing in a plain text password, which we then encrypt via the GenPassword utility and outputting the newly generated encrypted password to be used in your PF. The minus prefix encoding value can be determined to best suit your environment. With the minus prefix, you have a choice of 4 options. AE1 considered medium strength, AE2 and OEP are considered strong, and OEC is considered weak and is deprecated. Store your database credentials in a hidden properties file to enhance security. This file is not directly accessible, reducing the risk of unauthorized access to sensitive information. Using a hidden properties file allows you to apply advanced encryption methods to both the user ID and password, providing a higher level of security compared to other methods. If you store credentials in the OpenEdge.properties file, you are limited to encrypting only the password using the GenPassword utility. This leaves the user ID in plain text. Within your PASOE startup program, you can dynamically set credentials using the setUserID method. This allows for more flexible and secure credential management during runtime. Programmatic management of database connections and credentials enhances security and flexibility. It enables you to implement more robust encryption and easily manage credentials as part of your application's lifecycle. Property files are used to store configuration details, including encrypted database credentials. They play a critical role in managing application settings securely and efficiently. In the screenshot, you'll see how credentials are stored in an encrypted format. This ensures that sensitive information like user IDs and passwords are protected from unauthorized access. The property file typically contains key value pairs where credentials are stored under specific keys. Here you can see entries like db1 dbuser and db1 dbpassword, but with encrypted values. Ensure that the property files are kept secure and access is restricted. Regularly review and update encryption methods to maintain security standards. Here we have a code snippet that programmatically sets the user ID. It will run as part of the PASOE startup procedure. In this example, we are looping through a list of logical database names. If the database is connected, then it checks a flag to see if the credentials require decrypting. It is valid to have decrypted credentials stored in your properties file for test and development environments only. For production, they must be encrypted. Once decrypted, we use the setUserID function to set the database connection to the specified user identity and the function returns a true value. If the credentials do not match, then it will return a false value, and we pass back an appropriate error message. Considerations. It's crucial to run your encryption program on the credentials before storing them in the properties file. This step ensures that sensitive information is protected from the outset. When creating new databases as part of the deployment process, particularly for applying delta.dfs, you must be aware that this may affect security settings. After creating new databases or making changes, security settings may need to be reapplied. This ensures that the security configuration are up to date and properly enforced. Implement a flag per database to track the security status, whether it's on or off. This flag helps manage and verify the security settings for each database, ensuring that they are appropriately configured. If the security flag indicates that the security is enabled, reapply security settings to maintain the desired level of protection. This helps prevent any lapses in security due to changes or updates. Okay, that brings us to binary-only deployments. Binary-only deployments offer two key benefits: protecting your source code and making your deployments more efficient. In this method, we only deploy compiled code, which prevents unauthorized access to your intellectual property. Additionally, by using PCT functionalities like PCT dyn run, you can still manage database operations, such as updating schema and data, without exposing any source code. This is particularly useful in environments where you need to separate the development and deployment teams, ensuring that sensitive code remains secure. In many deployment scenarios, effective database management is essential. This includes tasks like updating the database schema and data to ensure the system operates correctly and efficiently. Updating the schema involves making changes to the database structure, such as adding or modifying tables. Data updates may include inserting or modifying records to reflect the latest information. The PCT functionality provides tools to facilitate these updates. Utilizing PCT functionalities can also streamline the process and reduce manual effort. PCT dyn run is a tool that allows you to run database updates dynamically. It helps in applying changes to the data during runtime, providing flexibility and minimizing downtime. PCT load schema is used specifically for loading and updating the database schema. It ensures that the schema changes are applied efficiently and consistently across the deployment environment. PCT dyn run is ideal for binary-only deployments, allowing automation of data loading. It could be used multi-threading that process to improve performance. It has the same parameters available as PCT run, giving full flexibility with parameters you can set. On completion of the temporary procedure, it returns a status value. Anything that is non-zero will throw an exception and fail the build. If your procedure requires parameters, then they can be passed using the PCT parameter option and picked up in the progress procedure using a dynamic function of getParameter. Likewise, you can specify the PCT output parameter to receive parameters from your progress procedure. Here is an example of an Ant script using the PCT dyn run function. You can see we are passing through a variety of settings, including tailored ProPath, DB alias, etc. We can also see parameters being passed to the specified procedure, and also an output parameter that populates a property in the Ant script. PCT load schema utility enables you to load database schemas in runtime-only environments. To achieve running this with a runtime-only license, we must specify the client mode of Rx, which is not a documented parameter. Also, if you're applying an incremental schema to a database with security switched on, then you will need to specify the -u and -p encrypted in your PF. That also applies to the PCT DynRun utility. Here we have an example of an Ant script macro utilizing the PCT load schema. Along with the client mode I mentioned, we also have the PCT connection where we are giving the physical database details. We can also specify -h and -s parameters instead, if required, or a PF file as mentioned before. We also have specified the single user. If you have multiple DF files to load, then that can also be achieved by specifying a directory instead of the source file. So moving on to passaway encryption. Storing unencrypted credentials in configuration files is a major security risk. To mitigate this, we need to encrypt these credentials. We should do this encryption as part of the deployment via our scripts. The two areas we will focus on are the passaway Tomcat users.xml and the server.xml. In this section, I will run through some examples on how to achieve this. Starting with the passaway Tomcat -users.xml, we will have prompted the deployment administrator for the passaway Tomcat credentials. We will then need to encrypt these credentials before writing them to the corresponding XML file. We use the digest command to achieve this, specifying a suitable algorithm for the encryption, for example, SHA-256. If neither handler nor algorithm is specified, then a default of SHA-512 will be used. Once we have encrypted the credentials, then we can write them to the passaway tomcat-users.xml file. Here we can see an example of an Ant script macro using the digest command to encrypt a given password. We have two attributes, one for the plain text password and one for the returning encrypted password. As you can see, we are generating a temporary file which we use as the output from the digest command, and we are using an encryption algorithm, which in this case is SHA-256. We then strip out the plain text password from the temporary file and populate the returning property with just the encrypted password. Finally, we delete the temporary file to tidy up after ourselves. After encrypting your Tomcat credentials, it's important to integrate your tailored credential handler into the passaway server.xml file. This ensures that our encrypted credentials are properly managed during runtime. Decide on the encryption algorithm to use. It should match the algorithm used during the encryption of your credentials. For example, if you used SHA-256 for encryption, then you'll need to specify SHA-256 in the credential handler configuration. The credential handler must be placed in the relevant realm component in the server.xml file. This is where the authentication and credential management are configured. If you're using a user database realm, the credential handler should be nested inside this component to ensure it processes the credentials correctly. Here we can see an example of an Ant script macro inserting the credential handler in the user database realm for the specified server.xml. We are using the XML task to achieve this, and you can also use XML validate task to verify your changes are correct if you wanted to validate your changes before proceeding. Here we can see the parent macro that calls both of the macros I previously showed. First, it encrypts the credentials by calling the macro encrypt Tomcat user password. It then writes the encrypted credentials to the relevant Tomcat users.xml by the use of the replace filter function via tokens in the template file. Finally, it inserts the credential handler by calling the Tomcat credential handler macro. Considerations. Any changes made to the configuration files, such as server.xml or Tomcat users.xml, necessitate a restart of the PASOE Tomcat service. This ensures that all changes are applied and the service operates with the updated configurations. The workflow that we recommend is begin by stopping the current PASOE Tomcat service. This step ensures that no processes are using the configuration files while you make changes. Next, unregister the service from the system. This step removes the service from the list of registered services and prevents conflicts during reconfiguration. Delete the old service to clear out any outdated configurations or remnants from previous setup. Set up the new service with the updated configurations. This includes applying changes to your configuration files and ensuring all settings are correctly specified. Deploy the new configured service. This step integrates the new service with our environment and prepares it for operation. And then finally, start the new PASOE Tomcat service. Verify that the service starts correctly and that all configurations are applied as expected. Okay, that moves us on to development workflow. To prevent vulnerabilities from being introduced into our code base, it's crucial to integrate security checks into our development workflow. Unit testing and peer review are two essential steps in ensuring code quality and security. You should also include security in your definition of done, or DoD, for each development task. That way, you can avoid trying to desperately add critical security measures into your application when it is too late. Security should always be included as an application evolves. So testing. Incorporating security thinking as part of the testing process is a great way to achieve this. Unit testing can include security checks that are fired automatically during our pipeline builds. Adopting a shift-left approach helps us identify and mitigate risks much earlier on and ultimately reduces the overhead in resolving these issues. Using DAST tools allows sophisticated scans, detecting vulnerabilities with minimal user interactions, once configured with hostname, crawling parameters, and authentication credentials. These tools will attempt to detect vulnerabilities in query strings, headers, fragments, verbs, get, post, put, and DOM injection. We have SAS tools can be integrated into the development process to help development teams as they are primarily focusing on developing and delivering software. For example, SonarQube can be used to scan a developer's environment and be used as a stage in a pipeline build to give us an up-to-date analysis of the code. Peer reviews are not just about code quality, they're an opportunity to enforce security best practices. During reviews, you can check for potential backdoors, insecure dependencies, or any intentional or unintentional introduction of vulnerabilities. For example, if the code introduces new third-party libraries, reviewers could verify whether these dependencies have known security risks. This process ensures that security policies are followed and that any issues are caught early before they reach production. This moves us on to the Jenkins pipeline. Implementing matrix-based security in Jenkins to define fine-grained permissions for different users and roles. This allows you to control access to various features and operations within Jenkins, enhancing overall security. The script console in Jenkins allows for the execution of Groovy scripts, which can pose a significant security risk if misused. Restrict access to the script console to prevent unauthorized users from executing potentially malicious scripts. Treat the Jenkins server as a black box to reduce exposure and potential attack vectors. Limit direct access and interaction with the server to essential operations only, and protect it from unauthorized access. Properly configure and manage credentials within Jenkins. Use Jenkins built-in credential management to securely store and handle sensitive information such as API keys, passwords, and other secrets. Regularly update Jenkins and its plugins to the latest versions. Updates often include security patches and bug fixes that address vulnerabilities and improve the stability of your Jenkins environment. Continuously review and access Jenkins security practices and configurations, and regular audits and updates help maintain a secure pipeline and mitigate emerging threats. Jenkins is a powerful tool, but it can pose a serious security risk if not configured properly. A key feature to mitigate this is the matrix-based security. With matrix-based security, you can control access based on roles and permissions, ensuring that only authorized users have access to critical actions. Unauthenticated users should have minimal access, for example, allowing them to run or cancel jobs only, while authenticated users can be assigned roles based on their responsibilities. You can adopt any authenticated user admin rights approach, but only if you tightly manage these users. If you do need a more granular access control for your authorized users, then adopting the appropriate authorization strategy for your organization is required. This screenshot shows the authorization settings configured using matrix-based security. The matrix-based security settings are displayed in a table format where you can see different permissions listed along with user or group assignments. Each row represents a user or group, and each column represents a specific permission or access level. Permissions might include admin rights, job configuration, view access, and more. Assign appropriate permissions to users or groups based on their roles. For example, you might grant admin rights to a specific group while limiting others to read-only access. Here we can see that any authenticated user admin rights approach has been adopted. The Jenkins script console is a powerful tool, but in the wrong hands it can cause significant damage to your environment. To mitigate this risk, access is restricted to the administer permission only. Another reason to restrict unauthorized users from admin rights. Similarly, we can run Groovy scripts directly from our build script if the Groovy plugin has been added. To manage security for these Groovy scripts, we can use the in-process script approval plugin. This prohibits the running of any new Groovy scripts until they have been approved by the Jenkins administrator. This screenshot shows the in-process script approval interface. The interface typically lists scripts that are pending approval. This includes information about the script content and the user who submitted it for approval. You can see options for approving or denying script execution. This helps control which scripts are allowed to run within the Jenkins pipeline. Carefully review the content of scripts before approving them to ensure they do not contain malicious or unintended commands. Use the provided options to approve trusted scripts or deny scripts that do not meet security standards. Regularly check the in-process script approval dashboard to stay on top of pending approvals and manage script executions efficiently. Implement and enforce policies for script approvals to ensure consistent security practices. Another best practice is to black box the Jenkins server itself. This means restricting RDP and internet access and placing the server behind a firewall or VPN. You should never run Jenkins or its agents as the system's administrator, as this gives them too much control over the operating system. Instead, restrict access based on the principle of least privilege, ensuring that users only have access to the resources they need to perform their jobs. This step is critical in reducing the attack surface and limiting the potential damage an attacker can cause if they gain access to Jenkins. Configuring credentials. So storing credentials in Jenkins for secure access during internal deployments. Credentials can be accessed via Groovy scripts and passed to relevant Ant scripts. We can adopt the same encryption approach for credentials as we used in the deployment scripts mentioned earlier. Storing credentials in Jenkins minimizes risk of hard-coded credentials in scripts and are easier to maintain. Don't forget to regularly update your Jenkins credentials and review access permissions for your necessary security audits. Here we see Jenkins credentials in update mode, accessed from the Manage Jenkins credentials option. Here we can add, delete, update, and move credentials. And we can then reference these credentials in our Groovy scripts from the specified ID. Here we have an example of a Groovy script that is run from a pipeline that is accessing some Jenkins credentials. In this case, it is referencing the Jenkins credentials ID of Tomcat service user. We then obtain the username and password from the Jenkins credential, and it is passed to the relevant Ant script to process accordingly. In this case, to deploy an instance of Tomcat. Jenkins and its plugins can become out of date quickly, leading to security risks. Some of the common reasons for update slippage are finding the time to properly test these updates and having many plugins to maintain. So allocate time regularly to test updates in a staging environment and housekeep deprecated plugins to give an accurate picture of what is actually required for maintenance. Maintain a test instance of Jenkins to validate updates before applying them in production. You can use the plugin manager to list available upgrades and apply them efficiently. Prioritize security related updates to ensure the system remains protected. Plugin Manager simplifies the process of upgrading Jenkins plugins. Regular plugin upgrades reduce vulnerabilities from outdated components. Select only necessary updates to minimize downtime and ensure compatibility. And test all updates in a controlled environment before applying to production. That leads us on to artifact storage. Securing your artifacts, whether they are binaries, libraries, or other deployment packages, is just as important as securing your code. By using a repository management system like Nexus or Artifactory, you can control access through role-based access controls, or RBAC. These systems also offer secure data transfer via HTTPS, ensuring that artifacts are safely transferred and stored. Caching external artifacts can protect against supply chain attacks by reducing the need to constantly download updates from external sources. In artifact storage systems like Nexus, you can create users and groups to manage access effectively. Assign specific roles to users or groups. These roles determine the level of access and actions that they can perform, such as viewing or modifying artifacts. Permissions can be set at a granular level, providing detailed control over what users can do within the repository. This includes actions like creating, reading, updating, or deleting artifacts. We can define permissions specific to individual repositories or groups of repositories. This ensures that users have access only to the artifacts they need and nothing more. Tailored access also improves operational efficiency as well as security. Regularly review and update roles and permissions to align with changes in team structure or security requirements. Monitor access logs to track who is accessing or modifying artifacts. This helps in identifying any unauthorized activities or potential security issues. Maintain audit trails of changes in roles and permissions to ensure compliance and facilitate troubleshooting. This screenshot displays the interface for managing roles in Nexus. Nexus has built-in roles, but you can create your own custom ones to fit your organizational needs. Within each role, you can manage the privileges available for that role, fine-tuning your roles for users at a granular level. Securing data transfer. HTTPS and SSL are used to secure communication between clients and servers. This encryption ensures that sensitive data, such as credentials and artifact files, are protected during transit. By using HTTPS and SSL, you prevent unauthorized access and interception of data, safeguarding it from potential eavesdroppers and ensuring data integrity. When utilizing a repository management system, such as Nexus or Artifactory, as a proxy for external repositories, for example, Maven Central, ensure that connections are made over HTTPS. Ensure that your repository management system and any associated servers are configured to use HTTPS. This typically involves obtaining and installing SSL certificates and configuring the server to handle secure connections. Clients' interaction with the repository should also be configured to use HTTPS to ensure that all data transfers are encrypted. Caching external artifacts. Repository management systems cache external artifacts to enhance security. Caching reduces the risk of downloading malicious or compromised versions. It also improves performance by limiting repeated downloads from external sources, and this helps protect against supply chain attacks in open source environments. Periodically verify cached artifacts to ensure they remain secure and up to date. So in conclusion, to summarize, we've covered a range of security best practices for DevOps pipelines, including database security, binary-only deployments, PAS-OE encryption, and securing the Jenkins pipeline. By integrating security into every stage of your development workflow and adopting tools like matrix-based security and artifact caching, you can significantly reduce your security risk. Remember, security isn't a one-time task, it's a continuous process that should be embedded in your DevOps culture. Thank you for your time today. I hope you found these insights useful and that you can apply them to your own environments. Okay.